The routes above 1,500 feet AGL are generally flown under IFR, and the ones below 1,500 feet are flown for the most part under VFR. 4-digit numbers indicate routes below 1,500, and routes above are designated with 3 digits. VR indicates visual route, and IR indicates instrument route.
You know, TFRs have become increasingly more important in the past few years. What are they?
Temporary flight restrictions are set to protect people and property in the air and on the ground from an existing or possible hazard. They can exist for a variety of reasons, like the president or vice president visiting an area, around disaster relief operations, and in areas where NASA is conducting operations. Nuclear plants are also an example of areas where TFRs may be established to protect people and property in the event of an accident.
Now, how do you know if a TFR affects your planned flight?
They aren't depicted on a chart, so I need to check NOTAMs to find them. TFRs are no-fly zones, so I would get all information about any TFRs along my route while on the ground and plan my flight accordingly.
Let's take a look at some of the sectional symbology. Show me some of the following on the chart. Abandoned airports.
This is a magenta circle with an X in the middle.
How about a military airport?
These are 2 concentric blue or magenta circles.
Airport elevation.
This is listed in the airport data box.
Airports with lighting facilities.
You can determine by the letter L in the airport data.
All right, how about this one? Airports with services.
By the ticked marks extending from the airport symbol.
Approach control frequencies, ATIS.
These are found in the chart margin, again in the airport data area.
How would you know the runway length?
This is in the airport data area, last 2 digits omitted.
If the runway does not have a hard surface.
By the open magenta or blue circle.
What does the dotted magenta circle mean?
An NDB.
Now, what's this magenta circle with the letter R in it mean?
That's a private airport.
You have a very good handle on chart symbology. Let's go on ahead and continue. While en route, we'll have to call to get an update on the weather and on what frequency.
FlightWatch, known as En route Flight Advisory Service. Their primary frequency is 122.0, but other frequencies may be used to contact the controlling FSS, depending on your location.
What are the standard flight service frequencies?
The controlling FSS frequencies will be listed above the communications box for that FSS. If the COM box is a heavy lined blue box, this indicates the standard frequencies are available. These are 121.5 for emergencies, 122.0 for FlightWatch, 243 and 255.4. Any other frequencies will be indicated.
Now, what if we're en route on a cross-country flight and no flight service station is nearby? How do we go about getting en route flight information?
Sometimes the FSS is remoted to an en route navaid. If this is the case, I'll receive on the navaid frequency and transmit on another specific one. RCOs are also available in certain areas.
Are air route traffic control centers of any use to you as a VFR pilot?
They can be. Controller workload permitting, some advisory or assistance services may be provided. Flight following is a good example. Of course, you have to know the appropriate frequency to contact them on, but you can get that from the controlling flight service or by referencing an IFR low altitude chart or AFD for the area.
An air traffic control facility can be of great help to a VFR pilot at times. It's important to know how to contact them. Now, during our cross-country flight today, tell me how you'll use radio navigation to supplement your dead reckoning calculations and your pilotage.
I'll be using the VOR to back up my navigation.
Okay, how will you determine the radio your airplane is from and a VOR station along our route?
First, I tune and identify the VOR station. Then I rotate the CDI until the needle centers and a from flag appears. And then I read the radial indicated under the CDI.
So if you're on the 270 radio from the station, where would you be in relation to the station?
West of the station.
How would you fly to a VOR station?
Tune and identify the station, rotate the OBS until the needle is centered and a to flag is indicated, then turn the aircraft to the heading indicated under the course selector index and keep the needle centered until station passage. If the needle goes right or left, I'll correct towards the needle.
And what is reverse sensing?
Reverse sensing occurs when the heading I'm flying is essentially opposite to the course selected. The CDI will move away from the selected course instead of towards it. So instead of correcting towards the needle, I'd have to correct away from it to make it center. I can avoid this situation by always ensuring that my magnetic heading agrees with the course I've selected.
Tell me, what type of reception distances can we expect from a VOR station?
Well, it depends on the class of station as well as the aircraft's altitude. Reception distances range from 25 miles to as much as 130 miles.
Now, how about checking the accuracy of your VOR receiving equipment?
There are several different ways to check. I can use a VOT, which is an FAA certified testing station, and I can also use airborne checkpoints as well as certified ground checkpoints. All these I can find in an AFD.
Here's a scenario for you. You become disoriented or lost on the cross-country flight. What will you do?
Well, the first thing is not to panic. I'll continue to fly a specific heading in a direction I believe is correct, or if necessary, I'll circle around a specific landmark. The idea is not to wander around aimlessly. If I've been flying a steady compass heading and keeping a relatively accurate navigation log, I should be able to locate my position. If several VORs are within reception distance, I can use them for a cross-bearing to determine my position. Even a single VOR can help a lot to narrow down my possible position. Another way to establish exactly where I am is fly to a VOR station. No doubt where I'd be then.
What if none of that works? What else are you going to do?
Well, by knowing my last known position, elapsed time, approximate wind direction, and ground speed, I can establish how far I might have traveled since my last checkpoint. Then, using this distance as a radius, I can draw a semicircle ahead of my last known position on the chart. If I'm still unsure of my position, I need to start doing what you call some first-class pilotage. I'd start looking for something big, like rivers, mountain ranges, prominent highways, or railroads. Once I could identify one, I could use it as a reference to get reoriented to the chart and then hopefully get an approximate fix on my position.
During all this, what are the most important actions in relocating your position?
The 4 C's. I climb, with the idea being that the higher the altitude, the better the communications capability I have, as well as a better visual range for identification of landmarks. Then I communicate by using the system. Center could be of enormous assistance if I could contact them. I could also use 121.5 if no other frequency produced results. If I were successful in establishing communications with someone, I'd confess my predicament. And last, I would comply with the instructions they provide. And if none of that worked, I would do my best to get the airplane on the ground as soon as possible. Otherwise, I'm no more than an accident waiting to happen.
Robin, that is exactly correct. Most accidents are the products of mistakes which have multiplied over a period of time, and getting lost is no exception. Never push your luck. It might be that in doing so, you'll commit the final mistake, which will add to another figure to the statistics of accidents. If terrain or other conditions make landing impossible at the moment, don't waste time. Don't search for the perfect field. Anything usable will do.
I hope I never have to use that advice.
Okay, Robin, here's our next scenario. You're in and out on a cross-country flight. Weather has deteriorated and it's becoming necessary for you to divert to an alternate airport. Tell me, what procedures are you going to use?
First, I'll mark my current position on the chart along with the current time next to my mark. Second, I'll take a look at my available alternates, considering distance, and select the one most appropriate for the emergency. Third, I'll determine a rough magnetic course to the alternate and divert in that direction immediately. I found that using a radial of a nearby VOR or an airway that closely parallels the course to the alternate is a good way to get me headed in the general direction. As I proceed, I'll compute wind correction, actual distance, and estimated time and fuel while en route to the alternate. A quick way to get a rough distance to my alternate is to place my finger at the appropriate place on a straight edge of a piece of paper and then measure the approximate distance on the mileage scale at the bottom of the chart.
All right, let's talk about some regulations affecting today's flight. What does Part 91 say about the responsibilities of the pilot in command in the event of an in-flight emergency?
The PIC is directly responsible for and is the final authority in the operation of the aircraft. Also, the PIC can deviate from any rule to the extent necessary to meet the emergency.
Now, if you do have an emergency, are you required to file a written report with anybody?
Only if requested to do so by the FAA.
How about in the event of an accident?
For something like an accident, in-flight fire, flight control malfunction, or property damage over $25,000, I need to notify the NTSB immediately.
And how would you go about doing that?
Look in the phone book government pages for the nearest NTSB field office. They also have a website with phone numbers for all the regional offices.
Now, Robin, what responsibility does the PIC have concerning passengers and the use of seatbelts?
I have to ensure that each person on board my aircraft occupies an approved seat with a safety belt and shoulder harness, if installed, properly secured about them during movement on the ground, during takeoff, and on landing.
Now, how about kids? Are they required to wear a seatbelt?
Yes, except for passengers that are under 2 years old who may be held by an adult occupying a seat.
Now, Robin, you're about to make a sightseeing flight in the local area. What do the regulations require you accomplish prior to the flight?
I need to get all the information I can about the flight, including runway lengths at airports I intend to use, and takeoff and landing data under the existing conditions.
Suppose you've flown over to a neighboring town and you're pre-flying the airplane now to return back home. You've noticed both fuel gauges are reading empty, but visual inspection confirms the tanks are topped off. Are you legal to make the flight back home if you placard the gauges inoperative?
No, fuel gauges are required to be working.
Okay, now let's suppose this. You lose your vacuum pump in the same type of situation. You've landed somewhere, but still need to make the flight home for repairs. Can you fly back without your vacuum instruments?
Yes, these would be the attitude and heading indicators, and neither is required by regulation under the list for day VFR equipment. In this case, I could placard the instruments and return home for repairs.
So suppose you're planning a flight over a remote area or maybe over mountainous terrain. How would you check your ELT to find out if it works?
In this particular plane, the ELT is mounted back in the tail cone behind the baggage area. It has a 3-position switch, on, off, and armed, and is normally set to armed. If I want to test the signal, I can turn the ELT on in the first 5 minutes of the hour and listen for the signal with my comm radio set to 121.5.
Speaking of flying over the mountains, when do you or your passengers need to use supplemental oxygen?
Well, I'm required to use oxygen for any part of a flight that exceeds 30 minutes above 12,500 feet. Above 14,000 feet, I'm required to use oxygen the whole time, and above 15,000 feet, passengers must be provided supplemental oxygen. But I think it's a good idea for me and my passengers to use supplemental oxygen above 5,000 feet at night and above 10,000 feet during the day.
All right, it's good to see you establish some of your own personal limitations. What can you tell me about the rules of right-of-way? Who has the right-of-way when it comes to different categories of aircraft?
To remember this, I use the acronym BAGAR: balloons, gliders, airships, airplanes, and rotorcraft. A balloon will always have the right-of-way over any other category of aircraft, a glider has the right-of-way over an airship, airplane, or rotorcraft, and an airship has the right-of-way over an airplane or rotorcraft. Aircraft towing or refueling other aircraft have the right-of-way over all other engine-driven aircraft, and aircraft in distress have the right-of-way over all other air traffic.
What would you do if you noticed you were approaching an aircraft head-on? Also, if you realized you will overtake another aircraft ahead of you, what would your procedures be?
Approaching head-on, I'd alter course to my right, and if overtaking another aircraft, I'd alter course to the right and pass well clear, since the other aircraft has the right-of-way.
And what is the minimum safe altitude that you can fly over a congested area or a city?
Except when I'm taking off or landing, I can't operate an aircraft over a congested area or over any open